The next example, y double prime minus y prime minus 2y equals t cosine of 3t. Let's first look at the homogeneous part. That has characteristic equation r squared minus r minus 2 equals 0. This factors as r minus 2, r plus 1. So my solution here is going to be a c1 e to the 2t plus a c2 e to the minus t. Great. Now for the non-homogeneous part. For this we see a t cosine of 3t. So that means when plugging in, I'm going to have to guess something pretty complicated because it's a polynomial times a trig function. So for the trig function, I'm going to want to guess a cosine 3t plus b sine of 3t. And then from the polynomial part, I'm going to want to guess ct plus d. So I'm going to end up with 4 terms here in my guess when I distribute this out. Now we see we should be okay here because neither of these terms or none of them here solve the homogeneous problem, so we're going to be good. Which means my guess is going to be a t cosine of 3t plus b cosine 3t plus ct sine of 3t plus d sine of 3t. That would be our guess. Now if I want to work out the actual solution, I'm going to have to take 2 derivatives of this and then plug it in. And it's going to get complicated, but if you're careful with the terms, it'll all work out. So for the derivative, we get a cosine of 3t, derivative falls on t, minus a 3at sine of 3t, and then minus a 3b sine of 3t. And for the sine terms, I get a c sine of 3t plus 3ct cosine of 3t, and then plus 3d cosine of 3t. To make my life easier, I'm going to collect some terms here. This equals a negative 3at sine of 3t, and the other sine term is this one here paired with this one. So I will get a plus a c minus 3b sine of 3t. And then I get a 3ct cosine of 3t. And then plus a plus 3d cosine of 3t, combining the first and last term here. I can now differentiate one more time. And the same terms come through. Minus 3a sine of 3t, minus a 9at cosine of 3t, and then plus a 3 times c minus 3b cosine of 3t. And for the cosine terms, I get a plus 3c cosine of 3t, minus a 9ct sine of 3t, and then minus a 3 times a plus 3d sine of 3t. And again, we'll do one more collection of terms here, resulting in this collection here, where I've basically grouped these terms in with their respective sine and cosine function terms. Now we can plug all of this into the differential equation, y double prime minus y prime minus 2y, to get the second derivative, minus the first derivative, and then minus twice the actual function itself, and I want this to match t cosine of 3t. So to do that, we got to collect a bunch of like terms here, and I will see each of the following for different coefficients. So the coefficient of t cosine of 3t on this middle part here is going to be a minus 9a minus a 3c minus 2a, remembering that this minus sign here distributes inside to every term in this middle set here. For t sine of 3t, we end up with minus 9c plus 3a minus 2c. For cosine of 3t, we get 6c minus 9b minus a minus 3d minus 2b. And for sine of 3t, we end up with a negative 9d minus 6a minus c plus 3b and minus 2d. And based on the right-hand side that I want this to be 1, this to be 0, this to be 0, and this to be 0. What am I left with? Well, I'm left with a system of equations. I have minus 11a minus 3c equals 1. I have 3a minus 11c equals 0. I have negative a minus 11b plus 6c minus 3d equals 0. And I have negative 6a plus 3b minus c minus 11d equals 0. Now I just want to solve this. I can solve these two first independently because they are two variables, two equations. So if we do that, I can multiply the first equation by 3, the second by 11, and then add them together. So I'll have 33a with the next one on top, 33a with a plus underneath. And I'll end up with then negative 9 minus 121 c equals 3. So c is going to be negative 3 over 130. And then from the second equation, I know that 3a is 11c. So that means that a must be negative 11 over 130. I can work those two into the third and fourth equations to give me another two equations to a known system to solve for b and d. And so if I do that, I will get that 11 over 130 minus 11b plus a negative 18 over 130 minus 3d equals 0, or negative 11b minus 3d equals 7 over 130. And the other equation gives me a negative 6a, so a 66 over 130 plus 3b minus, so plus 3 over 130 minus 11d equals 0, or 3b minus 11d is negative 69 over 130. I can solve these two in the same process as the first two that I solved. They are actually the same coefficients with a different right-hand side. If I do that, I can again multiply this by 3, this by 11, add them together. So I end up with, again, negative 9 minus 121d equals 21 over 130 plus negative 69 times 11 over 130, which this here is 759. So that, take away 21, means this is negative 738 over 130 divided by another 130 gives me that d is positive 738 over 16900. And then since 3b is negative 69 over 130 plus 11d, 3b will equal negative 69 times 130 plus 11 times 738 over 16900, or that b is negative 284 over 16900. So there's b, there's d, I have a, and I have c, which means after all of that, I can now write my general solution. So for my general solution, I am going to get y of t is the homogeneous part, just c1 e to the 2t plus c2 e to the minus t, and then plus the non-homogeneous part, which will be at cosine 3t. A here was negative 11 over 130. So minus 11 over 130 t cosine of 3t plus b cosine 3t minus 284 over 16900 cosine of 3t plus ct sine of 3t. C was negative 3 over 130. 3 over 130 t sine of 3t. And then plus d sine of 3t. D was positive 738 over 16900. 738 over 16900 sine of 3t. That is a lot of work and a lot larger system than you probably ever be asked to solve by hand at any point. But the point is, it's here, you can do this, right? It takes a lot of work and a lot of sort of organization, keeping things straight, but it does work out and will eventually get you to an answer for this kind of a problem.